Let's build a MiniTokio to execute the future returned from asynchronous code. First, let's define a structure. Give the name MiniTokio. Let's add two fields to this MiniTokio. First field, let's give the name Q. We use this field to receive task, so its type will be receiver from standard library sync. In this receiver, we will add a arc task because we will share the reference to this task, so we will put the task in this arc. Under this task, we will later define this task. Second field, let's give the name sender. We will use this field to send the task, so its type will be sender from standard library sync. Also arc task. Let's define this task. So struct task. Let's add two fields to this task. First field, let's give the name task future. Because we will mutate this text future across thread, so we will put it in a mutext. So mutext from standard library sync. Hold a task future. Later we will define this text future. Second field, let's give the name sender. We use this sender field to send this task itself, so its type will be the same type as this sender. So let's copy this. Let's define this text future. Struct task future. Let's add one field to this text future. Let's give the name future. We will put a future in a box, and this box will be pinned. We will put the pinned box in an option. So option pin box dyn future. This box dyn future means a treat object. Let's give this future output type an empty pair of parentheses. So this future will return nothing. Let's also add a send and left time static. This send means this future can send across threads. This static is a left time. Let's implement arc wake treat for this task. We need to add the futures to our dependency. So in Kagura.ml, let's add futures version is 0.3 to our dependencies. So let's implement arc wake for task. And we need to implement a method wake by ref. So -wake by ref. When we call wake method, it will call this wake by ref method. So when we call this wake by ref method, we want to send the task itself. So in this method body, let's just send this task arc self the sender to get the sender. Then we will call send method on this sender. Then we will send this arc self. Let's clone this arc self. This send method will return a result. Let's call unwrap to handle the result. Let's implement a method for this MiniTokio. So impl MiniTokio. First, let's add a function new to create an instance of this MiniTokio. So returning type will be MiniTokio. Let's create a channel. So let's create a tuple. In this tuple, we will have a sender and a receiver equal to, we will call channel function from standard library sync. This channel function will return a tuple. This tuple contains the sender and the receiver. Then let's return an instance of this MiniTokio. So MiniTokio, and this Q will be receiver from its channel, and this sender will be this sender from the channel. Let's implement a method for this MiniTokio. We will use this method to send the task. So let's give the name spawn. First, we need to declare a generic type parameter. Let's give it a name f. First parameter should be a mutable reference to self, so ref mute self. Second parameter, let's give it a name f, and its type will be this generic type parameter f, and we want this second parameter's value be a future. So let's use where to bound the trade with this generic type parameter f. So f will have trait future, and output empty pair parentheses plus send plus lifetime static. In this method body, first let's create a task future. So let's create a variable, give the name task future equal to task future field should be some hold a box pin. We will call pin function from box, so it will create a pinned box. Then we will pass this f parameters value into this pin. Then let's create our task. So let's create a variable, give the name task. This task should be in arc, so let's create a new arc new function. Then task first field is task future, and this task future should be in mutext. So mutext new, and we'll pass this task future in this second field should be sender. We will get the sender from this self. So self.sender we will call clone method to clone this sender. So this task will get the sender from this MiniTokio. Last, let's send this task. So self.sender.send task.unwrap. Let's define a method to execute the future. So let's create a method fn, give the name run, and the first parameter also will be a mutable reference to self. So ref mute self. This method will return nothing. In this method body, let's use while let loop to consistently receive a task from a channel. Also destructure the task in OK. So OK, let's give the inner value a name task equal to self the q we will call recv method to receive task from this queue. This recv method will return a result. If it successfully receive a task, it will return an OK hold a task. In this while let block, let's get the task future from this task. Let's create a mutable variable, give the name task future equal to task the task future. This task future in a mutext, so we need to call lock method to access data in this mutext. Then let's call unwrap to handle the result this lock return. Then let's create a if let sum. In sum, let's create a mute variable future equal to, we will call text future. Then we will call take method on this future. Because this future is an option, so we call take method. It will take that option and return that option. Then it will leave a null to this field. So if this option is a sum hold a future, we can get this mutable future from this text future, and also leave a null to this future field. In this if let block, let's create our waker. Let's create a variable, give the name waker equal to, we will call waker ref function to create a waker from this task. We will pass the reference to this task into this function as argument. It will create a waker from this task. Then let's create a context. Let's create a variable, give the name context equal to mutable reference context. So ref mute context from standard library task, and from waker function to create a context from its waker. We will pass the reference to its waker into this from waker function as argument. Then let's create a if block future that we will call as mute to create a mutable reference to this future. Then we will call pull method on this future. We will pass this context as argument into this pull method. Then we will call its pending if we call this pull method on this future, and this pull method return is pending, so this is pending method will return true, then we will put this future back to this text future in a sum. So let's dereference this text future and put it in a pair of parentheses. The future field equal to, we will put the future in a sum. So we will put this future back to this future field in its text future. So if this is pending is not true, it will not put this future back. So this text future field will be a null. So when the future field is a null, this if let block will not be executed. So it means this future is completed. Let's create a sync function. A sync hyphen hello. In this function, let's just print out hello. In main function, let's create an instance of this MiniTokio. So let's create a variable MiniTokio equal to MiniTokio new function. And this MiniTokio should be mutable, so let's add a mute keyword before this variable. Then let's call MiniTokio.spawn method. Let's pass the async block as an argument. So async. In this async block, let's call this async function hello await. Then let's call MiniTokio.run to execute the future. In terminal, let's cargo run. So you can see it will print out hello. Our MiniTokio successfully executed the future from its async function hello. This is how we build a MiniTokio. Hope see you next time.